Alrighty, so our first set of notes for this module kind of tells us all about being a function. Okay, so if you can kind of imagine a pop vending machine, we're trying to determine will it function or not. So kind of what we're thinking about is every input on our vending machine, which we're going to consider the buttons, should produce one single output that never changes. Okay, so if I were to walk up and push the Coke button on the pop machine, a Coke should come out. If you were to walk up behind me and you also push the Coke button, a Coke should come out, right? No matter how many times that Coke button is pushed, a Coke should come out. That is a function. Now, if I walked up and pushed the Coke button and a Coke came out, you walked up behind me and pushed the Coke button and a Sprite came out, okay? That would not be functioning because that one input or button had two different outputs. So that's kind of what we're looking at here, okay? And it's pretty simple when you're looking at ordered pairs. You're just looking at the inputs, okay? So I am looking for any inputs that are going to repeat. And remember, the inputs are the X values of the first numbers in the ordered pair. So -2, -1, 0, 1, and 2. All of those inputs are different, okay? The only time I'm concerned if any of them are repeating. So I would say function. Or yes, it is a function. Okay, let's look at number 2. So let's look at my inputs. 4, 8, 6, 4. So I see 4 repeats. Now what I need to double check is, does that same input have the same output? So the input of 4 has an output of 0, input of 4 has an output of 3. That one input has more than one output. So I would put not a function because of input 4. Okay? All right, now let's look at some different representations of data. So number 3, we have to realize that these are our ordered pairs, right? So I check these inputs. Do any of them repeat? I see that 0 repeats with 2 different outputs. So I would say not a function. Okay, and that would be because of the input of 0. Okay, so I look here. Do the inputs repeat? This has a single arrow coming from it. This has a single arrow coming from it. This has a single arrow coming from it. Each input has its own output. It's okay if 2 of them share the same output. Like if you think about some pop machines have like 2 different Coke buttons. Those share the same output, but they're 2 different inputs. Okay, so that is still functioning properly. So I would say this is a function. Okay, so go ahead and try 5 through 8. Pause the video, try 5 through 8, and then go ahead and play when you're ready. All right, so number 5 I see has an input of 5 that's repeating, so this is not a function. Number 6 looks like all my inputs are different, -4, -1, 2, and 5, so this is a function. Okay. Number 7, none of my inputs repeat, so this is a function. And on number 8, we can see that this one input has 3 different outputs, right? So this one input has 3 different outputs, so I would say not a function. Okay. All right, so if every input has its own output, that's how we know it's a function. Now, if we're checking a vertical line test, if we're checking on a graph, okay, each x value, okay, so each x value or vertical line would represent a single input. Wherever it hits the function is its output. So this input right here has one output right here. This input right here has one output. This input right here has one output. So if each vertical line is only hitting one point on the graph, it is a function. If, as you can tell in the second example, I have one input that has 2 different outputs, so one vertical line that hits the function twice, or excuse me, hits the graph twice, that's how you know it's not a function. All right, let's look at page 2. Go ahead and try to determine, using the vertical line test, try to determine 9 through 14 if they are functions or not. So go ahead and pause, do 9 through 14, and then you can play when you're ready. Okay, number 9. So I see this point right here is good because it hits once, but this point right here, or this vertical line right here, hits twice. So I would say that's not a function, okay? Number 10, checking vertical lines, they're all good. That is a function, okay? Number 11, all the vertical lines look good, right? So that's a function. Number 12, all the vertical lines look good, right? So 12 is a function. Number 13, you can already see with one vertical line it's going to hit twice. That's not a function. 14, good, good, good. Good, good, that's a function. Okay. So if my vertical line hits twice on the graph, it is not a function. Let's go ahead and look at page 3. Oops. So we have some fancy names for inputs and outputs, or when you group all the inputs and outputs together. We call the set of all the inputs or x values domain, and the set of all the range values or y values or outputs range. Okay, so all the inputs or x values are domain, all of the outputs or y values is range. Okay, so finding domain and range, if I'm looking at a graph, first thing I always want to do is just label the ordered pairs. So this ordered pair all the way over here is negative 1, 2, 3, negative 2. So negative 3, negative 2. This one up here is negative 1, up none, so 0. This one is over 1, up 2. And this one is over 1, 2, 3, up 4. Okay, so once I label those, domain and range is pretty easy. Domain, and we use these little braces, is all of the x values. So just list out your x values. Negative 3, negative 1, 1, and 3. The only tricky part here is make sure if any of your domain or range values repeat, you don't write it twice. So range is all my y values. So all my y values would be negative 2, 0, 2, and 4. And it honestly doesn't matter what order you put them in. They don't have to be in order. I just kind of do that because it makes sense to me. All right, so go ahead and pause the video, try number 16, and then play when you're ready. All right, so ordered pairs here. Looks like I have negative 2, comma 4. I have negative 1, comma 2. I have the point 0, 0 right there at the origin. I have positive 1, comma 2, and positive 2, comma 4. Sorry if there was a jump in the video there. Hit a button. Okay, so now I'm ready for my domain and range. Domain, all of the x values, I have negative 2, negative 1, 0, 1, and 2. And none of those repeat, so I can write them all. My range, got to be careful with it, right? I don't want to repeat values. So I have a 4, I have a 2, I have a 0, I have another 2, so I'm not going to repeat it, and another 4, so I'm not going to repeat it. So the only tricky part there is we don't want to repeat values. Okay, so those are your function notes.